So yes, I was saying that I'm using Canva. I've used it to create the presentation. I found it kinda cool. It offers some templates you can create your presentation upon and some free elements. Okay, anyway, so let me start. So today's workshop will be about the software testing. We will be talking about different approaches and types of testing, and you can see the agenda for today. We will talk about the software testing definition, and we will compare manual and automated testing. We will talk about the software development and testing life cycles, and we will list the testing approaches, testing categories, and we will talk about some of the most common testing types. Okay, so let's start by defining what is software testing. In theory, software testing is the process of evaluating and verifying that a software product or application does what it is supposed to do. And yes, so from our technical perspective, the software testing means that you will check that your project should be bug free application, and it also contains some higher level testings like performance testings and so on. So you're basically testing whether your application is meeting the requirements and is outputting correct values and is working with how you are expecting it to be working. So yes, why should we invest time in testing our softwares? This is because during the history of softwares, there were some bugs which arose and costed the companies billions in terms of actual money, or in terms of some medical faults, or even some businesses were out of market because of some software bugs. And I have put a link in here that you can follow to check the most expensive bugs in history. Okay, I have put this quote in here, which says, I do believe it's important for testers to know the market that their client or their employer is in. And the reason for that is if you understand what the risks your client is facing and you understand what the competing products are, and so on, which basically means that you will need to check the severity of your software. So if your software is a medical software that lives depend on, you will have to pay great attention and invest much effort and time in writing tests, sorry, in testing your software. Okay, so the first comparison for today will be between the manual testing and the automated testing. To define manual testing, this is the process of testing manually. So an end user can create his own script, or can maybe test the user experience of some software by hand. So this is not automated. How can we distinguish between this and the automated testing? We can ask ourselves who is doing the testing. If the human is doing the testing, so this can be considered a manual testing. The other testing type is the automated testing, which is basically by a human using tools and these tools will perform the testings. So again, how can we confirm that this is an automated testing? We can ask ourselves the question, who is doing the testing? And if a tool is doing the testing, then this can be considered as automated testing. I have also put a link in here which describes the differences between them in more details. Okay, so before going into the software testing cycle, let me talk about the software development life cycle that we currently use. We're currently using the iterative life cycle, which means that we develop each feature, and so for each feature we develop, we analyze the requirements at first, then we create a design solution, then we build the actual feature, and then we perform the test. Okay, so this is kind of the waterfall model, but with it's not our topic. So anyway, the problem in here is that at this stage, okay, it will cost you very much. It will cost a lot to refix an existing bug. So you may have an error in the requirement analysis. So you maybe understood the requirements wrong, and you went all the way through the cycle, and then when writing tests, you have noticed that you had an error in here, or you misinterpreted something, or in the solution design. This is why this cycle is somehow outdated, and it was then replaced with a V-testing model. What this is about? This model is about when we first start the analysis of our requirements, we also plan our acceptance tests. So in each step of the development life cycle, we also plan the testing life cycle at the same time. This way we can make sure that, okay, this is working fine, this is working fine. We can go all the way to actual coding, and after coding we can start executing the testing plan that we have previously set. So before actual coding, we plan how the unit test interfaces will be, and how will the input and output of each function that we have wrote. Of course, we should like write functions without implementations, and we write the corresponding unit test. So in this way, you will see that your project, or your software is building without defects. Okay, this is called the V testing model. I have put a link in here describing more about it. Okay, this is another code which says, no amount of testing can prove a software right. A single test can prove a software wrong. So it really isn't about writing lots of tests. It's about writing the right test, or testing right. Okay, so right now we will talk about the testing approaches. So, in software testing, we have three different approaches, which are white box testing, black box testing, and gray box testing. So, a white box testing is testing with the internal perspective of the system is known. So, in this testing model, you have access to the actual code and you can see it. Okay, so this testing is usually done at the unit level, and we also have the black box testing. In this testing approach, you don't have an access to the actual code, or you don't really care about the actual code. You only are interested in the maybe the API, how the data will flow from input to output. And we also have the gray box testing, which is a combination of these two. In this model, of course, the tester should have the high-level design, solution designs, and should also have exposure to the actual code. Okay, so right now I will talk about the testing categories of the software testing. So we also have three different categories. We have the functional testing, the non-functional testing, and the maintenance testing. So the functional testing is a test that checks whether the application is working. So it should be working. Okay, this lies below the functional testing. An example of these include the unit tests and the integration test. And in the other hand, we have the non-functional testing, which only cares about how well the application is working. This category includes performance testing and endurance testing, scalability, usability, and so on. So you know that your software is working, but you're interested in some other aspects of this software. And the third category is the maintenance testing, which kind of makes sure that the life cycle of your software is always maintained. So whenever you introduce changes to your code, for example, you should make sure that the existing features are still working properly and fine. Okay. One example category is the regression test category. Mm-hmm. So, first of all, I will talk about the unit test. It is also known as model testing or component testing. And this is the absolute first level testing type. This testing type considers testing each component in isolation. So you're testing individual components, uh, and each developer working on different modules, each one will have to develop his own unit tests. And to do this, if the models will like connect afterwards, we can use mocks and the stubs, and we will talk about this later. So yes, the importance of the unit test is that it will find bugs in the early stage of software development, and it will make sure that the model that you're working on is working as expected. This is a white box testing, so you have exposure to the code, and it lies below the functional testing as well. So you're interested in making your features or functions or classes or modules work. Okay. Another type of testing is the integration testing. It is also known as INT, integration and testing, or string testing. So yes, this is the second level testing type. It considers testing the connection between the modules. Okay, so it's not a an individual models testing. It's composed of connecting these models together and testing how the features will work. It makes sure the API is working properly. This is also a white box and functional testing. It has four different approaches: the top-down approach, bottom-up approach, Big Bang approach, and hybrid approach. We won't be talking about these. One note I will give it is the Big Bang approach, which states that you start writing your integration test right after all the features or all the models are ready, which indeed sounds like time consuming. Okay. So yes, in integration test, we also can use mocks and stubs, but these will only be used to mock in external connections, for example. Whereas in the unit test, we will also mock other internal components. So yes, we also have the end-to-end test, which is also kind of known as system testing. So this is the third testing level. It considers testing a real life feature from the client's perspective. We do have such tests in our code base we're using Cypress, I recall. So yes, one note I have to add in here is that I consider the integration test and the API client and the micro client as end-to-end tests. They are not integration tests as far as I can tell. The integration test in the D3A and D3A web are indeed integration tests, but in the API client and micro client side, I can consider these end-to-end tests because we're testing from the client's perspective. Anyway, So yes, the difference between integration test and end-to-end test is that in integration test we're testing how different modules connect, but we're absolutely not testing whether the whole system is working. Unlike the end-to-end test, which will test the whole feature, and yes, it falls below the black box testing, so you're not really interested in the code. And this includes functional and non-functional testing, so you can test whether the feature or the system is working and whether it is scalable, and test the performance of the system and so on. So yes, it falls below these two testing types. And the absolute last testing is the acceptance test, which will be conducted by external or by the requirements writers. So yes, the user will compare the final product with the initial requirement, which was initially a text or a set of requirements. So he will make sure that the requirements are met, and this also falls below the black box testing, and it will test both functional and non-functional testing. It includes three types, which are alpha, beta, and gamma. The alpha type is that the tester will give responsibility to the inner developers to test the product. The beta testing means that some external users will test the feature as well, or the product. And the gamma testing, which is kind of the same as beta, but in a higher in a wider range. So yes, that's it. And I'm welcome for any question. Mm-hmm. Can you hear me? I can't hear anyone.
I can't hear you either, Paulo.
Yeah,